When temperature is kept constant, the relationship that we find is that the pressure of a gas varies inversely with the volume of that gas. Okay, so Boyle's law states that at constant temperature, the pressure of a gas varies inversely with the volume of the gas. So what does that mean? Earlier we said that when something varies directly, if one goes up, the other goes up. So if something varies inversely, what does that mean? So for something to vary inversely, Boyle's law says if pressure goes up, volume's going to go down. And if volume's going to go down, then pressure is going to go up. That's assuming that temperature is not in the play, doing some messing that relationship up. Okay. So if you were to represent Boyle's law, it would look the opposite of your Gay-Lussac's law. So Gay-Lussac's law, when something went up, the other thing went up. So it was a straight line going that way. But Boyle's law, if volume is going to the right like that, you'll notice that pressure is going down instead of going up with it. Okay. So this is how you would represent Boyle's law instead. And once again, your units are with a slash, your pressures with a slash as well, and you're titling your graphs as y-axis versus x-axis. The SI unit for volume is cubic meters, okay? SI unit for volume is cubic meters. We like to work with liters a lot in concentration and things like that, but when you're doing the ideal gas law later on, you need to have it in M3. But like I said, when you're doing like P1, but when you're relating two different points like P1 and T1, things like that, as long as the same unit, it's fine. But later on, we will have to start using M3 exclusively. Okay, so if you have pressure varying inversely with volume, in the last law, because it varied directly, we had P is equal to KT. But now that we're doing Boyle's law, because it varies inversely, what you get instead is P is equal to K on V. So rather than multiplying with it, it divides. The reason for that is because if your volume goes up, then your pressure goes down. Okay, so that's because it's on the denominator now. If your denominator gets bigger, your pressure goes down. So similarly to last time, at a single point, it's going to have the same constant. Okay, so if you were to multiply this over, you get PV is equal to K. So PV is equal to K, and at any single point, the constant's going to stay the same, which means at one point, P1 V1 is going to be the same as another point, P2 V2. Okay, and similar to Gay-Lussac's law, this equation is going to be the one that's more useful for us. So rather than PV is equal to K, because that's only looking at one point, P1 and V1 is equal to P2 V2 allows you to relate two different points together.